Hi guys, and welcome to the next session on quantitative methods. And we are moving into reading 2 of study session 1. This is where things start becoming probably a little more interesting in terms of statistics and how. So we are slowly from time value of money functions, which are mostly financial mathematic calculations, which are pretty easy and repetitive. Now we are going into something related to data. Okay, so there's a strong progression towards analyzing data, and this is the first step towards it. Okay, so let's start with the first concept out here, and first let's look at the LOS out here, right? The learning outcome statement. As I always say, we need to keep an eye on what exactly is expected from us to know in this entire reading. So there are quite a bit of LOSs, but fortunately, the second reading of quant is somewhere pretty light and easy to understand if you're able to link it with real market data, right? So starting with comparing data types. Okay, so let's look at how to remember the different data types, and that's best done when we are actually looking at examples. Okay, so if we look at numerical data, remember the first study session or the first reading of time value of money, all the future value of investment calculations, the number of compounding periods, all of them fall under the numerical data types. Okay, so very easy to understand. Any financial mathematical calculations that you're doing is finally numerical. Okay, first I will discuss the first categories, and then we will move on to some examples, right? Categorical data is an example would be, for example, if today if you were to go and try to understand different sectors, right? So let's say there is an IT sector, the business is operating in. There's a BFSI sector. There's a, let's say, a consumer discretionary products sector, right? All these would fall under categorical data, right? Now we'll come to different types, but let's first look at what are the different other types of data, right? Cross sectional, right? Cross sectional is like saying that if we were to analyze, let's say, India, and we are looking at India and all the other Asian countries like, let's say, Nepal, Bangladesh, etc., and we are trying to analyze their inflation for a specific month. Okay, that would be an example of a cross-sectional data, because you're just looking at a specific month and a specific set of countries that you're trying to understand, right? So that's an example for cross-sectional. Time series is just straightforward data across periods. So if I were to analyze the Infosys stock, or let's say if we have Infosys stock price data for let's say 3 months, so then that would be qualified as a time series data, right? Structured versus unstructured data. Now think of it as, you can say, ordered data. Okay, that means there is some thought process behind this data. So somebody has actually had the intention to collect this data at the first place. So that would be called as a structured data. For example, stock prices data that you actually download from NSC is structured, because it's just not random, right? Versus unstructured data is something related to social media posts, because there's no specific order to that. Everybody is posting anything, right? So if you were to look at the data and try to analyze it, you will have to first structure the data at the first place before you can even do some analysis, right? So those are some of the examples. But let's look at in case of numerical also, there are some types. Okay, so there's one called as continuous, and then there's called as discrete, right? Now why are we saying continuous versus discrete is because if we look at the compounding periods, let's say I said that, okay, numerical data, so I'm talking about the n, the number of periods, as 6, right? So then there are certain values only which this n can take, right? For example, let's say I'm talking about an investment that I'm going to do, right? So let's say I'm going to do an investment for 3 years, right? Or I might say that I'm going to do an investment for 3.5 years. But will you ever ask me what is the investment I'm going to do at 3.001, 3.002, or 3.001? So this wherein the values can take any of these number is called as a continuous data, right? So continuous numerical data, that is what they mean, right? And when you look at discrete, that means there are only specific values you would be interested in, right? 2.5, 2.6, not really a continuous series, right? So when you are finding a future value of investment, you can't really say that it is going to take discrete values, because the value can be in fractions and continuous. I mean, it can just be linear, right? When you're trying to find out the future value, it can take any value, right? So that's the difference between continuous and discrete, right? Categorical also has two types. One is called the ordinal data and one is nominal data, right? Now, when I said the sectors, then there are just, I mean, when you say nominal, then you're saying that it has no real meaning in terms of other than just to categorize a data into some sections, right? But ordinal data would be a category, but then you're trying to put some order into it, right? So, for example, if I were to take a mutual fund investment and I want to categorize them across high risk and low risk categories, right? So maybe I created a category of 1, 2, 3, and 4, in which the first category is, let's say, a high risk uh, category mutual fund. Then this is above average risk category. Then there is average risk, and then there is below average. So there is an order here, right? So based on some characteristics of the data. But in case of nominal, you just based on whatever sector the business is performing on. There's no good and there's no bad out here, right? It's just based on whatever the business environment you're operating on. On the basis of that, I've categorized that as nominal, right? All the others are pretty straightforward to understand. But if you try to remember this slide, because frequently there are a lot of questions in the CFA exam that can show up asking you which data type is this. So if you understand this through examples, it will be clear to you. And I'm not saying that you limit to the examples which I took here. You should actually go and try to look at other data types and see where what type of data does it fall into, right? The reason why we actually study data types is because any analysis, statistical techniques that we might use depends finally on the type of the data, right? So same techniques cannot be used for all kinds of data, right? So you need to understand that. Let's look at the second LOS, which is talking about describe how data are organized for quantitative analysis. Please understand the key word here. The LOS says describe, so not necessarily calculate, okay? But unless you don't calculate, you really don't understand, right? So I feel that the CFA curriculum has oversimplified this. At the same time, they've not given enough context for this. So I'll try to explain this, okay? Whenever as an analyst you're trying to look at data, you might, let's look at the example out here, right? So you've got dates and you've got Nifty 50 prices, right? For some trading days, right? Now, this is a one dimension in data because the only dimension that you're looking at is time, right? So all you're concerned about is time, and then there is stock price. But if you want to perform certain analysis, let's say if you want to find out what is the return which got generated out here, right? So maybe I want to analyze the return. Maybe I want to also look at risk, right? Maybe I also want to look at some risk adjusted performance calculations like Sharp. So now I would require another dimension, right? So and also in the time front, so this could be the quality side of the data, and then you could also adjust the time by stating that, okay, why don't we look at data from 3 different time periods? So let's say we look at one data stating that we try to analyze from 2016 to present, right? The other method could be stating that, okay, let's try to look at from 2017 to present, right? And finally, we could also look at stating that, okay, let's also look at from 2018, to present, right? So if you were to, obviously you can't do this in one dimension, right? So you'll have to create another dimension. That's what I've given an example out here. So this is Nifty 50. But now I've added one dimension of the qualitative aspect of data. So I can see that from 2016 onwards, if I look at returns, Nifty tends to give me 15%. But if I look at from 2017 onwards, again 15%. But if I look at from 2018, then it gives me a return of 13%. Same way for standard deviation, right? And same way for some other data types like sharp, right? So this is one dimensional versus two dimensional. Again, the reason why I'm giving you an example out here is so that you don't have to really memorize this. Okay, let's go into the next LOS. So now we are covering two LOSs: interpret frequency and related distributions, and describe ways that data may be visualized, okay, and used for specific visualization. So basically, we are now looking at uh, how do we start analyzing the data and how do we visualize data, okay? So again, it won't be possible unless and until we actually look at some data, real data. Then it will become something that you will appreciate, okay? So again, I'm sticking to the Nifty data, okay? I've also attached a spreadsheet which if you want to refer to, which I will show you, but if you want to refer to, you can definitely refer to in the PPTs itself that you get with Mentor Me classes. But first, let's explain, right? So this is again my data set. I have some trading days out here. I have closing prices of Nifty, and I have the daily percentage change or by how much the index values are changing on the third column, right? Now, the LOS says that tabular format. How do we analyze basis tabular format? Okay. So what I might be interested in is that how many times a certain value is repeating itself so that I'm able to conclude something about the data. Okay. So maybe I want to ask the question is that, tell me how many times on a series 1% daily return happens. So I'm asking how many times is this happening, right? How many times is it happening that the daily returns is 0.5%? Or I might just say that how many times the returns are between 1% and 2%, right? So you have to understand that finally the percentage change, the returns of the data or financial data like this is a continuous data. So you can't really have exact 1% happening every day. That means you need a range, right? So whenever you analyze data, if you want to create a range of analysis, first you need to find out what is the maximum value during a certain period and what is the minimum value. So if I look at the data set here, then my maximum daily fluctuation has happened to be as 1.8%. And my minimum fluctuation that has happened is negative 0.665%. So if I were to now create a range, I would start with, let's say, I start with negative of 0.67 as my lowest point of analysis and 1.83 as my highest point of analysis, right? Now in spreadsheet, of course, it's very easy to do this because you can use different functions, which I'll just show you quickly. But for the purpose of explanation, first let's get rid of the concept, okay? So the first frequency that I'm looking at is the range between 0.67 and 0.17. Now you might ask that how did I decide what is going to be the range differences, right? So if I see between these value, how did I decide how much should be my bin frequency? This is also called as bin frequency because this is the range, this is the value, and you want to find out by you want to decide what will be the difference of counting. So you might say that okay, between 1% and 5%. So in this case, my bin range is 4%. So how do you decide that? Well, it depends upon how long. There's no particular science for this. But if let's say your maximum range was, if your maximum value was 20% and your minimum value was, let's say, minus 50%, right? Now you need to take an educated guess on, do you really want a cramped up data or do you want a basic a round figure where you can do the analysis, right? So there's no particular science to this. It depends upon how you want to visualize the data. So I've taken a very small frequency change, so you can clearly see that I've taken a 0.5% range difference, right? So it's about so my bin range would be called as 0.5%, okay? Because the data that I'm looking out for is not too wide, right? The highest is only 1.8 and the lowest is only negative 0.665. So now what we are trying to count is how many times did the values happen between 0.67 and 0.17. So the frequency that comes up to be is 1. So that's also called as the absolute frequency. For the first data point, the relative frequency is nothing but 1, which is the frequency for how many times this has happened between 0.67 and 0.17, divided by the total observations. So if I divide 1 by the total observations, then that will give me the relative frequency. As simple as that. So you just want to look at this data out here in a percentage term. That's it. That's all is relative frequency, right? Now, you might also be interested in knowing that, every time I just don't want to look at each frequency and say that how many times this has happened. So how about just accumulating the absolute frequency itself? So if you see, you've got 1 here. So if I ask you the question that how many times occurrences have happened till negative 0.17, so what would you do? Logically, on common sense, you would just add 1 plus 2. So your cumulative frequency would be 3. Then you might ask the question that how many frequencies or how many observations have happened till 0.33. So you'll just add 3 to 9 and that should give you 12. So that is nothing but cumulative absolute frequency. Now, if you try to convert this into a percentage value, which is nothing but the 12, right? The cumulative frequency is still here, divided by the total observations, which is nothing but 21. So that would give you the cumulative relative frequency. So both have their purpose, because from a return aspect, if you were to ask a question, how many how many returns are negative, then your answer would be it is 14.28%. And how many returns are positive? So you might just say, okay, 100% minus 14%, so that's about 95.23% returns are positive, right? So there is a use, but you need to understand from an example point of view what is its real application. Okay, so that's how data gets arranged in a tabular format from a theoretical angle. Okay, but when we actually look at the sheet, that's where it becomes interesting. So let's just move on to the sheet. Okay, so we are in the sheet. It's always fun to look at the CFA concepts on with real data and in spreadsheet, because that's what is the purpose of doing CFA. Why would you do CFA if you can't really apply it in real world, right? So we're with the same data set. Okay, small data set just to prove a point, and you can see that I've calculated the maximum fluctuation using the max function, and then I found out the minimum function. You don't necessarily have to do it in spreadsheet. Okay, if you want, if you are the curious ones, you can definitely do it. But even if you just watch it and you get it, it's okay. All right. So now the idea was, as I said, you wanted to create a bin, right? You wanted to create a range. So you found out the maximum value. Now you need to start with the lowest value. Let's say it start with 0.665 negative. And then remember that I created a bin range of about 0.5%, right? So I'm going to do that. And we're going to extend it till we reach 1.8, right? So we have reached till 1.83, right? Now, in Excel, it's very easy. You can obviously use count functions also, but there's a very nice function called as the histogram function. So I'm going to go to data analysis and I'm going to use histogram function. And I'm going to select the input range. So this is the data source where Excel is going to count for us. Okay, so this is my input range, and my bin range, as expected, it is asking us. So we've already created the bin range, right? And now it's asking where do you want the output. So we want the output out here itself. So let's see if it does not mess up things out here. Okay, there you go. So it has messed up, but that's okay. So we'll just get rid of anything which we don't want, and we'll just keep the frequency, right? So there you go. That's your relative frequency, right? So that's nothing but relative frequency. Pardon the spelling out here, right? So all it is trying to tell us is how many times has the data in case of 0.67 happened between below this until 0.67, right? From here, it is trying to find out what is the amount of occurrences happening between this value and this value, and so on. So it keeps on continuing. So that's relative frequency, right? Now, if you were to convert this, right, this is absolute frequency actually. Okay, relative frequency is actually percentage, right? So if you want to find out how many times this happens, so you just divide this by the total number of observation, right? So it tells us, okay, 4%, right? So it just tells you the intensity of this uh, frequency which is happening. It just tells you how the quantity of the fluctuations, right? Then now if you want to find cumulative absolute, so then as I said, you just need to accumulate. So last year plus, the last value plus this value, and I drag this down. There you go, right? And just convert this into percentage figure will give you a cumulative absolute frequency. Okay. Now, what I'm going to do is quickly, since this again gets covered separately as a histogram discussion and frequency polygon, it's best understood out here. If you just create a chart of this, let's say if I create a chart of this, it becomes histogram. Okay, this is histogram. This is nothing but histogram. There you go. Okay, this is covered in a separate LOS, but I don't think so. That's pretty useful. Okay, now if I create a separate chart of, let's say, the bin and the cumulative relative frequency, then this becomes nothing but frequency polygon. There you go. Right? So that's nothing but cumulative frequency polygon. And if you want to interpret this, just look at it properly. Okay, so it's giving you a very nice information. It's stating that till here, there are about 20% observations. Till here, there are about 60% observations which have already happened. Till here, there's about 90% observation. And then finally, it reaches 100%. So it's a very useful chart when you actually convert it into a chart. Okay, there are multiple ways by which you can actually put the frequency polygon also inside the histogram itself, right? So as I said, when you look at real data, you really don't have to memorize. Okay, so now let's go back to the boring PPT. Okay. So the same thing which I showed you on a spreadsheet is I had made it and I had put it across so that if in case you're not interested in making the sheet, you could directly skip to the slide and see what it looks like. Okay, so anyways, we are done with this, so we'll move ahead. Let's look at what is called as the contingency table. Okay, so sounds very complicated, but let's see what it exactly is. Okay, so the frequency table in which the variable stock returns are summarized. So okay, so if you look at the left hand side, okay, you will see that all you have is various sectors. Okay, so you could say that this is categorical data on the left hand side, right? And after this, after just putting a category to various industries, then now you are trying to categorize them further into stating whether this is, a large company, a medium-sized company, or a small company, right? So sounds very complicated, but all you're trying to do is taking sectors and then trying to classify them into some ordered data, right? Or you could say this is also called as ordinal data, right? If you look at the first slide, we spoke about ordinal data, right? So there's some order to it, and then this is just nominal categorical data. So when you combine both of them, you've got contingency table, right? So if you want to still look at, this is with real data that I've actually calculated. So if you want to look at, you can of course refer the spreadsheet. Okay, interpreting the contingency table. Well, if you look at this table, right, you can see that these are numbers, so it's very difficult to actually make sense of it. So if I just try to convert this into a percentage number, it becomes much more simpler to look, right? So if you see, just look at those high numbers, right? So I can see that IT companies greater than 100 billion are about 28%, right? If I look at healthcare, so medium-sized companies are maximum, right? If you look at financials, so you've got pretty mid-sized companies are pretty high, right? But you could conclude that biggest companies are in information technology companies, followed by healthcare, right? And finally, by industrials. In medium size, you could conclude that okay, if, healthcare are the largest amount of companies, and financials are second largest. And less than 50, you could say that okay, the largest amount of companies are in discretionary, consumer discretionary, right? So that's nothing but contingency table. Now there's something called as the confusion matrix, uh, wherein you are again taking the same data which you had, but now you're going a step forward and looking at there's some other characteristics like less than 20% performance and more than 21 performance in EPS, let's say. Okay, so now what you're trying to do is how many companies are generating less than 20% growth in EPS on these sectors. So that is nothing but confusion matrix, because you're taking some more data types or data characteristics and then trying to analyze them further. Okay. So all you need to understand at this LOS level is what this is, not really know how to calculate this. Okay. Now visualizing data. So there are multiple ways of visualizing the same data which we have presented out here. Okay. But I will show you a chart by which you can actually logically you can identify which chart actually makes more sense. Okay. But for the sake of knowing the name of the chart is why we are looking at this site. Okay, so this is a simple clustered bar, nothing but it's just giving you a count. Okay, all it is trying to give is a count. Okay, in clustered bar, now you are adding some information. See here, all that you have an information also to present is just a count. So it doesn't make sense to take any more, any different type of charts. So a single clustered chart can, make sense. But now when you're looking at clustered, let's say this kind of a clustered bar, you're adding more information, but you can clearly see that it's not very neat, right? Because these three colors are, pretty stacked up together. So it's not really giving you too much information, right? So what you can do is you can use a stacked bar instead. So what does a stacked bar do is try to put these three colors in one simple bar itself, right? So you can easily make out by the color variation that which type of company based on the size of the company dominates that sector. So you can see that telecommunication services is, half is large, and either you have very small companies, right? But look at something like a healthcare, right? So you have significant amount of large companies, and then you have significant amount of mid-sized companies, and then you have a large amount of small cap companies, right? Look at something like financials. You got a lot of small size companies, majorly I think because of fintech revolution that is happening, right? Look at consumer discretionary, majorly lot of companies, because so many companies are coming up with so many products which people can take, right? Look at IT, right? So either companies are very large or the companies are very small. So this is how it becomes very interesting, right? And now again, this information which you have out here can also be presented out here using a tree map. Okay, so tree map is already available in Excel. All you need to just take the data and just put it and it will come. And it just tells you the number of companies. So not much can be done, but if you want to really flaunt a little bit, can be done using tree map. Okay, word cloud. When you're dealing with unstructured data, right? For example, if you want to track what Elon Musk tweets, and you really want to find out those keywords that he talks about, which might be useful for analysis. Still, you can't really structure that data in a line chart, so maybe you would prefer creating a word cloud. Now, there are Excel does not really have a word cloud which you can use, but there are other functions, there are other applications like Tableau and Power BI which can be used to create word clouds, or also a lot of cloud-based solutions are there, applications are there which you can use to create a word cloud, right? But from an analysis perspective, this has limited use. Okay, line charts are used for time series data is or continuous data is amazing. Specifically, you're talking about investments, You're talking about, let's say, risk. You're talking about standard deviation. So line charts can be very, very useful because it has this continuous nature. So although investment returns can also be shown in clustered bar, if you're presenting annual returns, right? So you just want to look at returns for every year, right? So something like this. Let's say you have uh, this as your time. So let's say you have 2016, 17, 18. So out here, probably a line chart will not make sense. So you just want to present how much return got presented. So let's say you say that, okay, it's 6% return. Then in 2017, you had, let's say, 12% return. Then in 2018, you had loss, so minus 5%. So the question that we come now to is, how do we choose? Okay, that is where we are good. Okay, this is the final type of chart. It's also called as a bubble chart. What you need to understand as a concept out here in the chart is that it's got line, so it is finally giving you, continuous data information. So this line is giving you, is actually getting used for the continuous data, right? Then you've got the value out here in terms of the scale of money, and this is your time. So this bubble is adding a fourth dimension of showing you profitability, right? So it's very easy to identify, okay, these are the years when there was losses, right? So beautiful chart actually can be very helpful when you're trying to present someone. This is also called as a scatter plot. Okay, now I've actually done this in a spreadsheet. If you want to, you can actually go and refer this. But I'll show you, I'll talk about the use of a scatter plot first. If, let's say, we as fund managers were deciding whether to add a gold ETF asset, or let's say we were a portfolio manager and we want to decide whether we should add gold in our portfolio or not. So maybe we want to understand how these two behave together, right? We want to understand what is the relationship, right? Now, it will not give you the exact relationship, but it will give you visually that if you see most of them, under a certain, section are moving together. That means there is some relationship, right? And also notice some extra outlier events, right? So you can see this is your the gold ETF, right? So gold is going up and Franklin Templeton or equity is going down. So that means there is also an inverse relationship sometimes. So there are some times when your Franklin is going up, exceedingly up, right? And then your, gold is going down. So that means this can give you, an idea that probably this can be useful for diversification, right? So that's what scatter plots gets used for. Okay, now this is also called as the heat map. Well, there is no function of heat map in most of the spreadsheets, but it's trying to again summarize the same tabular data that we had, right? The same which we showed in the tree map. Again, you're trying to show it in a heat map. The only difference is you're using two sections of data. You are looking at categorical data here. This is categorical, right? And then you are looking at ordinal. I mean, categorical nominal and categorical ordinal, which means ordinal means nothing but the quality aspect of the data, right? So I think that's much is enough. Now let's move into the same LOS which I was talking about. How do you select a visualization type, right? So although the CFA curriculum has given a certain flowchart, but you can't really remember the flowchart all the time. So in practical sense, all you need to understand is answer three questions, which is what is that you want to present, to whom do you want to present, and how. So the chart type should be the last part on how. Okay. Usually people get confused here because they don't know what to present, and then they'll just take any chart and then present, right? So how is what this flowchart is going to answer. Okay. So for example, out here, what to explore. So what do you want to explore? Do you want to explore the relationships like we did in case of gold ETF versus equity? So then probably scatter can be useful, right? If you want to find out the distribution of a data under some categories, so is it a numerical data, is it categorical data, or is it unstructured data? So if it is numerical, then you know that you can calculate frequency, so you can use histograms, you can use frequency polygon, right? If you have categorical data, like the sectors in which the company operates, then we saw that a bar chart, a stacked, a clustered bar can be useful, a tree chart can be useful, a tree map can be useful, a heat map can be useful. If you have Elon Musk's comments, then a word cloud can be used. If you're trying to compare, well, most likely the comparison and the distribution is more or less simple, the same, because again in categories also you will be using the same type of charts, right? But time, right? When you're looking at continuous data, right? Actually, this also should be about continuous data. Specifically, when you're talking about investments, then a line and a bubble line can be useful. So, line will directly present the value itself, but bubble will add an extra dimension of maybe adding loss or profit, right? So that's how you choose the type of chart that you want to use while presenting data, right?